Hello, in this video we'll be doing an activity based on quadratic pattern, and this will be a summary of all the things which we have done under quadratic sequences. So due to time and space consumption of these questions, I have decided to attach them on separate slides. This will be 1.1 and this will be 1.2 and 1.3, and this will be 1.4 and 1.5. So we're going to start with 1.1. 1.1 says give the value of the second difference, and that is for 2 marks. We are given the quadratic pattern -9, -6, 1, x as well as 27. So with this, let's try to come with the second differences. Remember, before we come with the second differences, we must first have the first differences. So our given sequence is -9, -6, it's 1, x and 27. So we're going to say that T2 minus T1. -6 minus -9 will give us 3. 1 minus -6 will give us 7. X minus 1 will give us x minus 1. And 27 minus x will also give us 27 minus x. And these are our first differences. Let's come with the second differences. So the second differences is going to be 7 minus 3 will give us 4. X minus 1 minus 7. And here we're going to say that 27 minus x minus x minus x minus 1. As long as a term has 2 numbers with it, for example like this, it's a binomial, make sure you put it inside the brackets when you subtract, or to be safe, always put what you are subtracting inside the brackets. So let's see what we get from this. Here we have 4, here we have x minus 1, and negative times positive 7 is -7. We'll have 27 minus x, and negative times x is -x, and negative times -1 is +1. And here we still have 4, we can bring it down, and we're going to have x here. We can add like terms, -1 minus 7 is -8, and here we can add the like terms as well. 27 plus 1 is 28, and negative x minus x is -2x. And these are the second differences. Now let's see, what did our question say? The question said give the value of the second difference. When they say the value, it means they want the constant, something that doesn't have a letter. A value is a number, 1, 2, 3, a number that doesn't have a letter. As long as you are talking about 2x, now they no longer want that as a value. It's an expression now, if it has a variable. So from the second differences, we are going to check which one has a number on its own. The second differences are these ones here, which I have circled. It's 4, it's x minus 8, and it's 28 minus 2x. So 4 is the one that is the number among the 3 that doesn't have a letter, so we can regard it as a value. So we can say that therefore the second difference, this is 1.1, the second difference is equal to 4. Even these are the second differences, but it's not a value, it's an expression. Remember, we have said when we were introducing the quadratic sequence that when we are doing the quadratic sequence, whatever that's here is the same as what is here and the same as what is here as well. That's why we say that the second differences of a quadratic pattern are constant. So these are the second difference. The second difference is equal to 4. We can go to the next slide to solve for the next question. So here they say determine an expression for the second difference in terms of x. You see, now they are talking about expression. So our expression in this case will be one of the two between x minus 8 and 28 minus 2x. Both of them are expressions. So when they are saying write an expression, it's any term that has a letter inside. So we're going to say that x minus 8 or 28 minus 2x. They are both applicable as expressions. So let's write our answer. That 1.2, an expression is x minus 8 or it's 28 minus 2x. I believe since it's 2 marks, each will take its own mark. Now let's go to 1.3. Determine the value of x. Oh, that is for 1 mark. We don't have to sweat a lot. So let's go to the previous slide to see what we have been doing. Remember that we have said that a second difference of a quadratic sequence are constant. This means that since here it's 4, even x minus 8 must be equal to 4. Even 28 minus 2x must be equal to 4. All these things which are here must be equal to each other. They must be the same. Hence we say constant. So what we're going to do is that we can equate the 4 to the x minus 8, or we can equate the 4 to the 28 minus 2x, or we can equate the x minus 8 to the 28 minus 2x. But the simplest one which we can use, we can equate the 4 to the x minus 8. Let's equate them. So we're going to say that 4 is equal to x minus 8. We're going to take the negative 8 to the left side and we'll change its sign. This will be 4 plus 8 is equal to x. This means that 4 plus 8 is equal to 12, and 12 is equal to x. Therefore, the value of x is equal to 12, and you get your 1 mark. Let's go to the next question. It says determine the 9th term in the sequence. To get the 9th term, to get T9, we will first have to find an equation of the quadratic sequence. I'm not going to use the method of simultaneous since most of you are not comfortable with the idea of simultaneous. So we're going to go back to our sequence and our differences here. We have subtracted, but we have written them in terms of variables. So what we're going to do here is we're going to write our second and our first differences without variables. Okay, let me erase here. We will know that these are our second differences. I still need the 4 here. Okay, so remember what I've said in the introductory videos, that in such cases, on the given sequence, we're going to say that A plus B plus C. And on the first differences, we're going to say that 3A plus B. And on the second differences, we're going to say 2A. Now, the basic form of our sequence is that Tn is equal to an squared plus bn plus c. So what we're going to do here is that I told you that in all cases you're going to start by solving for a before you can solve for b and c. So we're going to say that 2a is equal to 4. Let's go and write it. We're going to say that 2a is equal to 4. That A is equal to 2 divided by 2, this case, the 2 cancels the 2. Then 4 divided by 2 is equal to 2. You divide both sides by 2 and you have solved for A. Then we go to the second one. We have said that 3A plus B is equal to the first term of the first differences. This means that this one is equal to this one. If you didn't understand, go to my introductory video or the one which I have posted on how to determine an equation of a quadratic sequence using method 2, not the one of simultaneous. So here we're going to say that 3A plus B is equal to 3, but we know that A is equal to 2. So let's go and write it. We're going to say that 3A plus B is equal to 3. Our A in this case is 2 plus B is equal to 3. 3 times 2 is 6 and 6 plus B is equal to 3. This means that B is equal to negative 3. We're going to take the positive 6 to the other side and we're going to say 3 minus 6 and we'll give you negative 3. Now we're going to go again and look for C. We have said that A plus B plus C is equal to the first term in the given sequence. This means that A plus B plus C, let me take down the page, A plus B plus C is equal to, what is the first term in the given sequence? That is negative 9. A plus B plus C is equal to negative 9. The value of A was 2, the value of B was negative 3, and we have C is equal to negative 9. We're going to add the like terms. Negative 2 minus 3 is negative 1. Negative 1 plus C, negative 1 plus C is equal to negative 9. Now, we're going to take the negative 1 to the other side, such that C is equal to negative 9 plus 1. It changes the sign since it has crossed the minus sign. Then our C will be equal to minus 8. This means that we can write our formula as Tn, we can write our formula as Tn is equal to A, that is 2n squared, plus B, okay, that's minus 3, minus 3n minus 8. That is the formula for the nth term, or the formula for the quadratic sequence. Since we are looking for T9, we're going to say that T9 is equal to 2 times 9 squared minus 3 times 9 minus 8. Let's use our calculator and see what we get. That is equal to 127. This means that term number 9 is equal to 127. When they say find the 9th term, you must first have the equation of the quadratic formula, of the quadratic sequence, and then where you see n, because we said n stands for the position, we're going to plug 9, meaning we are looking for the value. Tn stands for the value found on a certain position, so we're going to look for a value that is found on position 9. This means that our n will be 9. I hope you understand that. Now, the other question says that, is it in this slide or in the next slide? Okay, 1.5 says, which term in the sequence has a value of 397? So, let's write it on a new page. So, we are saying that which value has 397. So here we are solving for n. Tn in this case is given as 397. we are given the value and we are going to look for the value of n. So what was our sequence? Our formula was that Tn is equal to 2n squared minus 3n minus 8. So where we see Tn, we're going to plug 397. As long as you are given that value and you are looking for the term number or the position, know that you'll be solving for n. And here we're going to plug 397 is equal to 2n squared minus 3n minus 8. Let's treat it as a quadratic equation, and let's take the 397 to the right hand side and equate it to 0. So 0 is equal to 2n squared minus 3n minus 8 minus 397. This is 7 minus 397. Then let's take down the page. So we are going to add the like terms here. 0 is equal to 2n squared minus 3n. What is negative 8 minus 397? That is negative 405. Negative 405. To be simple, we're going to use the quadratic formula. Factorizing this thing will be a bit difficult. So we're going to say that the quadratic formula says that n is equal to negative b plus or minus, in bracket we have got b squared minus 4ac over 2a. This means that n is equal to negative. In this case, our b is negative 3 plus or minus, in brackets we're going to have, let me zoom in the space, in brackets or inside the square root, it's going to be b, that is negative 3 again, negative 3 squared minus 4 times a, that is 2, times c, that is negative 405, and then we're going to divide by 2a, which is 2 times 2. Let's check if we have plugged everything correctly. It's negative b, which is negative times negative 3, plus or minus the square root of, and open brackets, negative 3, that is b, the a is 2, the c is negative 405, and our a below is 2. Now, because we are saying plus or minus here, we're saying plus or minus, we're going to get two answers. Let me plug this into the calculator and see what we get. The first answer is that n is equal to 15, and the other one, let's see, negative 27 over 2. According to mathematics, a position can never be negative. Okay, your teacher cannot say to you, where are you standing? How far is the distance between myself and you? And then you say, oh, I'm standing at position negative 9. No. Distance cannot be negative 9. It's not applicable in real life. A distance will forever be positive. So in this case, you will say that this is non-applicable. There's no solution for this one. This means that n is equal to 15. What does this mean? They asked us to find a position where we will find 397. Where we will find 397. It's 15. So we will find the term 397 on position number 15. I hope you have understood everything that has occurred in this lesson. Thank you for watching.